Okay, next we are going to find the trigonometric Fourier series for the periodic signal shown in figure below. This is the signal given in the question. Okay, let us analyze the signal. The positive, this is a square wave of positive amplitude +1 and the negative amplitude is equal to -1. And if we look at the signal, we can say that this signal is symmetrical about the horizontal axis or the time axis. Means this signal is symmetrical about the time axis. So we can say that there will not be any DC component here. Okay. That means A0 will be 0 in the corresponding Fourier series. Okay. And again, one more thing we can understand that the signal is symmetrical about the vertical axis. Means the signal is symmetrical about the x of t axis or amplitude axis itself. I will demonstrate that. If I fold the signal about this x of t, both signal will coincide each other. Okay, both signal will coincide each other. That means the signal is symmetrical about the vertical axis also. Otherwise, we can say that the signal satisfies a condition x of t is equal to x of minus t, which means the given signal is an even signal. Okay, these are the things to be noted. Okay, now let us solve the problem answer. We can say that the waveform is symmetrical with respect to time axis. The given waveform is symmetrical about t axis. So A0 component will be 0 in the Fourier Fourier series. Again, one more thing to be noted is the signal, as I told you earlier, the signal is symmetrical about the vertical axis also. That means x of t is equal to x of minus t. Means if we fold the signal about the vertical axis, the left hand side and the right hand side will coincide each other. If we fold this paper about the vertical axis, that means implies that a signal is even signal. As I told in the previous lecture that if a signal is even, then Bn will be 0. Okay, Bn component will not be there if the signal is even. Now let us calculate the time period of the signal. Time period is the duration of a complete waveform. If we start from here, the signal goes high or signal goes to positive amplitude, then for a duration of 2, the amplitude remains at 1, then amplitude goes to -1 and the signal retains or remains at -1 for another duration of 2. Okay, so the time period of a signal is the duration of a complete signal. That means this is the time period from here to here or from here to here, whatever it may be, both will be same. I'm going to take the time period is from -1 to 3. That is the duration of a complete wave, means a single positive cycle and a single negative cycle together constitute a complete wave. Therefore this will be the t0. Okay, so what will be the magnitude of t0? T0 is equal to, from -1 to 3 we know total duration will be 1, 2 plus total time period will be 2 plus 2 is equal to 4 seconds. That means 3 minus 3 minus minus 1 minus 1, that will be 4. Okay, 4 seconds is the time period. Then what will be omega 0? We know that 2 pi by t0 is equal to omega. Okay, implies omega 0 is equal to 2 pi by t0 is equal to 4 is equal to pi by 2. Omega is equal to pi by 2 here. And what about the given signal x of t? X of t is 1 if the signal varies from -1 to 1, and x of t is equal to -1 if the signal, if the time is from -1 to 3. Let us express this using functional representation as x of t is equal to 1 from t equal to -1 to 1 for -1 less than or is equal to t less than or is equal to positive t. Okay, x of t goes to -1 and remains at -1 from 1 to 3. Means x of t is also equal to 1 for t less than or equal to 1 to 3. Okay, 1 less than or equal to t less than or equal to 3. Now let us write the equation for Fourier series. Fourier series of continuous time periodic signal is equal to a0 plus sigma n is equal to 1 to infinity an cos n omega 0 t plus b n sin n omega 0 t. This is the basic equation for the continuous time Fourier series. In this case, a0 is equal to 0, it's equation number 1, and bn is equal to 0, equation number 2, and this one equation number 3. Okay, if we substitute a0 and bn in this equation, the Fourier series contains x of t is equal to 0 plus sigma n equal to 1 to infinity an cos n omega 0 t plus bn is equal to 0. So second time will vanish. So what we obtained is x of t is equal to sigma n equal to 1 to infinity an cos n. What about omega 0? Omega 0 is equal to pi by 2. So cos n pi by 2 t. That means x of t is equal to sigma n equal to 1 to infinity an cos n pi by 2 into t, where an is equal to 2 by, what if t0 is minus, t0 is 4 here. Anyway, we are going to write the basic equation over t0. X of t cos n omega 0 t dt. This is the basic equation for a. So substituting for t0 and the limit of integration as well as omega 0 is in this equation, we get an is equal to 2 by, what is t0 here? T0 is 4. Integral, the signal varies from -1 to 3. Okay. -1 to 3 x of t cos n, what is omega 0 is pi by 2 n, pi by 2 t dt. Okay, then let us split this x of t. What is x of t here? X of t is equal to 1 for the interval between -1 to 1, and that is equal to -1 for the time duration from 1 to 3. Okay, so let us split this limit of integration as a 2 by 4 is equal to 1 by t is equal to, from -1 to 1, x of t is equal to 1 into cos n pi by 2 t dt plus second integration is from 1 to 3. Corresponding amplitude is equal to -1, means x of t is equal to -1 from t equal to 1 to 3. Okay, 1 to 3, x of t is equal to -1 into cos n pi by 2 t dt. Close the bracket, which is equal to 1 by 2 integral -1 to 1 cos n pi by 2 t dt plus 1 to 3 -1 can be taken outside, plus into -1 cos n pi by 2 t dt, which is equal to 1 by 2 -1 to 1 cos n pi by 2 t dt, plus into minus become -1, 1 to 3 integral cos n pi by 2 t dt. Now we need to know what is integral cos x dx, that is equal to sin x divided by d by dx of this angle. Okay, this is the formula, d by dx of this angle. You need to know the value of integral cos x dx. So by using this formula, let us integrate integral cos n pi by 2. Okay, that is equal to integral cos n pi by 2 t is equal to sin n pi by 2 t divided by d by dt of angle. D by dt of angle is equal to n pi t. Okay, we can this limit to -1 to 1 minus this one is equal to sin n pi by 2 t divided by d by dt of this angle n pi t. Limit of integration -1 to 3. Okay, and close the bracket. Now this one is equal to 1 by 2 sin n pi by 2 t divided by d by dt of n pi, sorry, by 2 is missing here, both sides. Angle is a pi by 2 t. D by dt of n pi t by 2 is equal to n pi by 2 minus this term sin n pi by 2 t divided by d by, again d by dt of n pi by 2 t is equal to n pi by 2 itself. First limit varies from -1 to, and the second one varies from 1 to 3. Okay, this is equal to 1 by 2 into first term becomes 2 by n pi, and sin n pi by 2 t, where t varies from -1 to 1, minus again 2 by n pi sin n pi by 2 t, where t varies from 1 to 3. Okay, 2 by n pi is common in the first time as well as the second time. So let us take it outside this bracket. We get 1 by 2 into 2 by n pi, and the remaining term in the first equation is sin n pi by 2 varies from -1 to 1 minus sin n pi by 2 t varies from 1 to 3. Okay, now 2 and 2 cancels each other, that is equal to 1 by n pi. Now substituting this upper and lower limits, we get sin n pi into 1 minus sin n pi. If we substitute t equal to -1, we get -1 by 2. Okay, minus, substituting upper limit in this equation, we get sin n pi by 2 into 3 minus, substituting lower limit 1 instead of t in the equation, we get sin n pi by 2 into 1. Okay, now this is equal to 1 by n pi times sin n pi by 2 minus, what is sine of minus theta? We know that sine of minus theta is equal to minus sine theta. Okay, you should know this equation. So what is sine of n pi, sine of minus n pi by 2, that is equal to minus sine n pi by 2. Okay, then minus sine 3 n pi by 2, minus into minus become plus. Expanding this bracket, on expanding this bracket, first term become minus, and then minus into minus become plus. Sin n pi by 2. Okay, again this is equal to 1 by n pi sin n pi by 2, minus into minus become plus, sin n pi by 2 minus, what is sin n pi by 2? Either you can leave this term as minus sin 3 n pi by 2, or we know that sin 3 n pi by 2 is equal to minus sin n pi by 2. Don't need to do that, you can leave it as minus sin n pi by 2 itself. Otherwise, this is equal to sin n pi by 2 is equal to minus sin n pi by 2. Okay, followed by sin n pi by 2. Again is minus into minus become positive. 1 by n pi times, sin n pi by 2, one n was missing here, plus sin this one n pi by 2, minus into minus become plus, sin n pi by 2 plus sin n pi by 2 equal to 1 by n pi here sin n pi by 2 plus sin n pi by 2 plus sin n pi by 2 plus sin n pi by 2 become 4 sin n pi by 2. That is equal to 4 by n pi sin n pi by 2. What was in the LHS? That is an. Mark it as equation number 5. Now substituting equation 5 in equation 4, we get this is equation number 5 and this is equation number 4. Okay, now substituting this equation 5 in equation number 4, we get, that means we are going to substitute for an in equation number 4. Then we will get x of t is equal to, this is equation number 4, sigma n equal to 1 to infinity. Instead of an we can use this one. Okay, instead of an I'm going to put 4 by n pi sin n pi by 2. Okay, instead of n I used 4 by n pi sin n pi by 2, then followed by cos n pi by 2 t. Okay, then we will get the Fourier series as this one. Now what we have to do is just substitute for n is equal to 1 to few times and find the minimum expression. This is the corresponding Fourier series. And you can substitute for n equal to 1 over here and solve for the base, solve for the minimal expression. Otherwise you can stop here. This is the